Now let us use velocity time graph to derive equations of motion. We will derive three equations which can be used to describe and calculate various quantities related to motion. Velocity time graph, and I am taking that at t is equal to 0, the velocity is u, and after a certain time say t, the velocity is v. I have taken this straight line, constant slope, it means acceleration is constant. So all these equations will be valid for constant acceleration. If the acceleration is varying, then these equations will not be valid. So at time 0, the velocity of the body is u, so we will take it as initial velocity u, final velocity v, and t is the time in which velocity changes from u to v, and let the distance covered in this time be s. So now, whatever we have done in graphs so far, velocity, time, if I calculate the slope v2 minus v1 upon t2 minus t1, that will be acceleration, and if I calculate area under the graph, that will be the distance covered by the body. It's not going in the negative half. One-dimensional motion, velocity remains positive in one direction only, one-dimensional motion. So distance and displacement will be same. So now let me calculate the slope of the graph first. Slope is the acceleration. So I will take 2 points, one this because velocity is known, and one this. What is the velocity here? v2 is v, v1 is u, t2 is t, t1 is 0. This point velocity v time t. This point velocity u time 0. So A is v minus u by t, or v minus u is equal to at, or v is equal to u plus at. This equation is called first equation of motion. Second equation is for the distance covered in the time when the velocity changes from u to v. And how do we calculate this? By area. So now let me calculate this area. We can take directly trapezium, or I can take one rectangle and one triangle. So S is half sum of parallel sides. For this trapezium, this and this, these two are parallel sides. What is the value of this? V minus 0. Another side, u minus 0. Half sum of parallel sides, v plus u. Distance between the parallel sides, t minus 0. So it is half v plus u into t. Now this is an important equation. We can derive second and third, both the equations actually using this. I will have to make use of first equation. V is u plus at. So I will substitute for that. Half u plus at, this is v, plus u into t. So what it becomes now? Half 2u plus at into t. Open this, half 2ut plus at square. And from here I can write this step here. Half into 2ut plus half into at square. So it becomes ut plus half at square. Distance covered is ut plus half at square. Now see, this is for constant acceleration. If there is no acceleration, acceleration 0 means the body is moving with constant speed. A 0, and then what are we left with? Distance is equal to speed into time. The formula we all are aware of. Speed is distance upon time, or distance is speed into time. When? When there is no acceleration, or when the body moves with constant speed. If the speed is changing and it is changing at a constant rate, acceleration constant, then this is the expression ut plus half at square. Okay, this is the second equation of motion. This is second equation. This was first equation. For third equation also we can use this expression. S is half v plus u into t. Or we can even use the final equation, second equation. In this equation we substituted for v, and then we got s is equal to ut plus half at. Now let me substitute for t. V is equal to u plus at. So v minus u is equal to at. T is equal to v minus u upon a. Now substitute this. S is equal to half v plus u into v minus u upon a, or 2as cross multiply v minus u, v plus u. What is it? Can you recall the expression? A square minus b square is a plus b into a minus b. I have used that identity here. B plus u, b minus u. It can be written as b square minus u square. And a, 2a get multiplied here, cross multiply. 2as is equal to this, or v square is equal to u square plus 2as. Took this on this side. So this is the third equation. Okay, so now v is equal to u plus at, s is equal to ut plus half at square, and v square is equal to u square plus 2as. These three equations are known as the equations of motion. U is initial velocity, v is final velocity, a is acceleration, t is time, s is the distance covered in this time t. These three equations are very useful and can be used to find out any unknown quantity given in the problem. Acceleration. Now imagine a situation. I am telling you something. This equation can be, here we may have minus sign also. When? If the final velocity is less than the initial velocity. V is equal to u minus at is also possible. If the body is moving in one direction and its speed is decreasing, when you apply brakes, the speed does not increase, it decreases. So final velocity is always less than the initial velocity. Then the acceleration is actually named as retardation. We call it retardation. So retardation is the name given to negative acceleration or deacceleration. Then it is minus. So we will have minus now. V is equal to u minus at, s is equal to ut minus half at square, v square is equal to u square minus 2as. Okay, now there are certain terms which you have to. Suppose I drop a body from certain height. What does it mean? Drop means its initial velocity is 0. If I throw a body in upward direction at maximum height, what becomes 0? Maximum height means it stops momentarily, it changes its direction and then it starts moving down. So when I throw some body in upward direction, it has some initial velocity, gradually it keeps on decreasing, at highest point 0 and then it starts coming down. So there are certain quantities which you have to keep in mind. Dropped, velocity will be 0. Thrown up, highest point, velocity is 0. Speed decreasing, acceleration negative. And these equations valid only when the acceleration is constant. So that's all from motion. Now in few classes we will discuss some numerical problems. Thank you.